Hey there, thanks for hanging in there with us. I'm Olivia Hillman. I'm on the security data engineering team as part of security operations at Benchling. This is my colleague David. Today we're going to be going over the concept of a cloud security baseline layer, how we define it, how we built it, and ultimately how you can benefit. First, some intros. To get everyone familiar, Benchling is a cloud-based platform for biotech research and development. As part of our work in helping our customers unlock the power of biotechnology, we're responsible for the security of the sensitive data that's associated with the scientific work, and identifying and addressing any consequent risk. And that's where security operations comes in, as Benchling's detection and response function. The job of security operations is to detect threats and malicious activity to the company and its customers, and remediate them as quickly as possible. Security data engineering is a subset of security operations, and we're responsible for building key services and platforms that enable this D&R workflow. For example, we run a threat detection pipeline that collects security telemetry from various sources, and it feeds it to our detection team so they can write tailored rules to identify threats. David and our colleague Brian presented on this yesterday, so definitely go back and watch that if you missed it. So who is this talk for? This is for security teams looking to scalably manage their organization's cloud environments without causing friction and slowing down engineering. This is for engineers that are responsible for deploying security services. And everyone else in this room, because there's something for everyone. We'll be discussing technical details, particularly around Terraform, but we'll aim to keep everyone on the same page so you'll still get the gist. By the end of this talk, you should have an understanding of common real-world threats to cloud environments, be familiar with the concept of a baseline security layer in a public cloud environment, as well as some idea how to build one. And ideally, you'll stay awake, but today at the end of a long conference weekend, I'll claim success at 50%. So now that we're aware of who we all are, we'll get on the same page about what typically goes into a cloud account, defining a security baseline, our implementation strategy and challenges, and we'll wrap up with a summary and maybe some time for questions. Great, let's get started going over cloud environments in a general sense. Here's an outline of your typical cloud account or environment. We've got the base infrastructure, network layer, compute, and application layer. But is there anything missing? Hopefully the name of our talk tipped you off. Security layer, layer 0, the foundations. And why do we need a security layer anyway? Let's take a step back and let's look at how cloud environments are breached today. Google's Cloud Threat Intelligence team publishes a quarterly report on real-world actors and compromises, and that provides a great source of information to use when shaping our security policies. Per the report, nearly 60% of cloud compromises can be attributed to lack of auth or just basic misconfigurations. With the sprawl of cloud services, it's easy to get config wrong, especially when you have many accounts managed by different business units without a standardized set of guardrails and policies. And developers shouldn't be the ones having to worry about getting those things right. They should have paved roads and cloud environments set up with secure defaults. But a baseline security layer encompasses much more than just standardization and base defaults. For example, let's take something as basic as a public S3 bucket. These are so easily identifiable by malicious actors that according to 2023 State of the Cloud by Wiz, if your bucket name's in GitHub, it can typically be exploited within 7 hours if you've accidentally made it public. If your bucket has a predictable name, like company secrets, or benchling users, or my super secret data, hackers can usually find and access your misconfigured bucket within 13 hours. So we know private data should not be in public buckets, but it happens all the time. This incident with airport data, uncovered by Sky High Security, exposed everything from employee IDs and photos, which could present a serious threat if leveraged by terrorist groups or criminal organizations, to things like information about planes, fuel lines, and GPS map coordinates. And directly from the security report, they highlight how simple yet so harmful a misconfiguration like this can be. So it's obviously important, but what is a security baseline layer? A security baseline presents a guardrail that puts the onus on the security team or engineers explicitly responsible for deploying security services to define and manage and maintain these services. This would remove the burden from other developers needing to make these decisions on a per-account basis. And security teams, they need visibility into cloud environments to enable things like cloud log sources, to identify and manage configuration and inventory, and more, in order to detect on and respond to malicious activity. The baseline provides a standardized way of doing that. The configuration should be consistent across the company, thus providing a foundation of hardened environments to make developers' lives easier. But how do you know if you and your company need one? Well, if you have multiple cloud accounts or environments, you've got more than one person working in the cloud, you want repeatable security configuration across accounts, you need to enable collection of logs and other security telemetry for threat detection and incident response work, and or you have expectations as a company to uphold particular standards for configuration and security. So after reading through this list, I'd bet the majority of you fall under at least one of these categories. Great, so let's help you figure out how to make one. A cloud security baseline should be a centralized platform. We want everything managed in one place for simplicity, clear division of responsibility, and uniformity in our foundation. This gives us consistency across accounts and a repeatable process to instill confidence in the deployments that are going out. The baseline should be self-healing and out of the way of production outage impact. It needs the ability to autonomously resolve issues based on a desired state. And further, any hiccup in the deployment process of your telemetry aggregation should not stand in the way of business as usual for developers. And finally, we want this baseline to apply the security as code philosophy. We'll get better quality security deployments by following software engineering principles. And we gain auditability with code as a source of truth to know what's in place across accounts at any given time. So once all these requirements are achieved, what does this enable for us? Well, security teams gain insights, telemetry, and centralized cloud governance. Engineers can work without worrying about deploying security services and defaults or having their work interrupted to do so. The business can move fast knowing that the baseline is covered, and your life becomes easier with security as a platform, developing and deploying security services faster and keeping up at scale. And now I'll pass it on to David to discuss in detail how we built this to enable these wins for ourselves.
So Olivia outlined kind of the goals for what we want to build or what we want to see in a cloud security baseline. So now let's talk about some implementation details and how we'd actually build something like this. So with all these things in mind, we kind of had a couple of initial challenges that we knew we needed to solve. We want to build something that continues to enable people to do their jobs, right? You don't want to have something that's continuously going to get in their way. So as we scale and as we continue to grow, we want to make sure that this kind of security deployment pipeline is working successfully. We're an AWS shop, so there's a lot of different things with, different regions, different environments to support depending on business use cases. So we need to make sure we have an ability to handle that as the business continues to grow. Roles and responsibilities, Olivia touched on this, but what's the distinction between the infrastructure team and the security team? Ownership, so not necessarily the technical side of it, but the people and the process side of it. Who responds if something breaks? Who gets the ticket? Who fixes it? What does ownership look like? So the hardest thing for us, honestly, wasn't even the technical side of this. Technical side was challenging, which we'll talk about, but it was really a culture shift and a paradigm shift for how we wanted to operate. And we're going to continuously say this throughout the rest of the presentation, but we really believe in a security as a platform approach rather than a consultant style. So pretty often you can have a business where you have your infrastructure team and you have your security team, and the security team kind of operates in an ad hoc manner where they will create docs, they will write tickets, they will give recommendations, and then it goes to the infrastructure team. And most infrastructure teams are usually underwater. They have their hands full with plenty of different things to do. And the last thing they want to do is get this continuous barrage of security requests kind of thrown over the fence that they then have to prioritize. There's never enough time in the day for anyone to get their work done. So a lot of security things go a lot slower than they possibly could. So we want to kind of shift this model and saying that, hey, we have, a security team that is more than competent, more than capable to do these things. Let's kind of manage and separate these duties out a little bit. And reduce the decision fatigue from infrastructure and developer teams to kind of worry about the security aspect. So it's a win-win for everyone. In order to kind of build this platform, we decided to leverage Terraform. This is what our company uses, so we wanted to standardize on that stack. You can do something with CloudFormation. You can leverage your ISC tooling of choice, but Terraform is what we use. And if you've never used Terraform before, just going to have one quick slide, which looks like it has much more text. So I won't read through all of it, but depending on your familiarity, there's really only a couple things that I want to call out. State refers to your collection of resources. So you have your IAC and you have your representation of what these resources actually look like in the cloud. And this is what you're going to look at to see like what exists, what doesn't exist, what the delta is. There's also a concept of a Terraform provider, which is the most important piece that I want to call out. Terraform provider is essentially an API plugin for how you're going to be communicating with whatever third-party API you're integrating with. In our case, this is the AWS control plane. If you leverage GCP or Azure, something else, there's specific providers for that. There's tons of different Terraform providers for a ton of different services, not even necessarily cloud providers. But really want to make that definition as clear as possible because this is where the crux of our technical challenge ended up being. So there's a problem in Terraform called, well, we're calling it the Terraform state problem, which is how do you kind of interact with different accounts in different regions to deploy a large number of resources. So remember that a provider is a plugin used to interact with third-party APIs. So if we want to manage AWS resources, we would use the Terraform AWS provider, which would take our resource declarations, call the relevant AWS APIs to get resources to a state that we requested. Well, also in Terraform, it requires us to create a unique provider per account and per region, because that's kind of how the AWS control plane operates. So if you want to deploy in EC2 in account 1 in US West 1 and US West 2, you're going to need two separate Terraform providers for that to handle the different regionality. You can imagine that this will start to break at scale. If you have n accounts times m regions, that's kind of the math that ends up happening, and you're going to end up copy-pasting stuff over and over again. If you have something as simple as 20 accounts, which is not a huge AWS deployment, and you have 10 regions that you want to support, across different parts of the world, you have 200 different module instantiations, which good luck trying to keep track of, and good luck kind of copy-pasting that code over and over again. It's going to be a nightmare. So when we first hit this, we were worried that we were missing something, so we were kind of looking for a fix. We found the GitHub issues page for Terraform, and you can see that we are not the only ones to run across this and not necessarily stoked about it. So you can see folks saying they love Terraform, but this is a major drawback, kind of an issue that's been open for a while, not really addressed. So from the HashiCorp support page, which documentation is really great, we love Terraform in general. There's a couple of different workarounds to solve this specific problem of how do I dynamically generate providers for different regions and different accounts. There's three options there. One is to use external tooling to auto-generate your kind of Terraform files. They recommend Bash or PowerShell. A popular one is also TerraGrunt. Essentially, the concept is don't repeat yourself. So how do you dynamically avoid the problem of repeating yourself? The second one is to pay for Terraform Cloud and leverage their provider to kind of create this concept of a workspace, which was defined on an earlier slide, and they kind of handle that for you. So you can create different workspaces and then use the workspaces to kind of handle your Terraform state, and then you don't need to reinstantiate providers. You can seed that context into a different workspace. Lastly is using the CDK for Terraform. At the time, we didn't really want to spend an innovation token on this. In my personal opinion, it's not really as fully fledged and developed as where it needs to be. So we really didn't want to risk our kind of production security workflows on something like this. We preferred to use kind of standard Terraform, which was much more proven and has a lot more support. So let's kind of look at all these options and see what we chose to do. So we kind of had a couple of different options. And so the first one was, hey, we're going to use some sort of tooling to auto-generate all of the Terraform for us. So we're going to write some custom bash scripts or maybe use TerraGrunt to kind of dynamically create things for us. We're not going to repeat it. We're going to seed some sort of config, have some code spit it all out. And in this example, the way that it's going to look is we have 4 AWS accounts. We want to deploy resources across 2 different regions. Regions are represented with A and B. Accounts are numbered 1 through 4. So for this, we need a bunch of different providers. So we wanted to kind of shard things vertically and say, okay, we're going to divide things into dev, staging, and prod. We're going to take all the dev accounts, put them in a single workspace, and then auto-generate the Terraform for it, do the same for staging and production. It's going to all flow vertically. There's a couple cons with this approach. You're going to need very heavy cross-account authentication because your workspace is going to need to go into all the accounts that are defined in it and apply Terraform changes there. So we didn't love that from kind of a least privilege model. More importantly, there's very tight coupling between different accounts and regions. So if you have a failure in 1B on the very left side, none of your changes are going to get propagated to 2A and 2B. So a failure in one account and one region for an arbitrary thing, things happen all the time, could result in serious issues and break your deployment. The other option is taking a horizontal approach, where we still split things in dev, staging, and prod, so that, following software engineering principles, we can kind of test our security baseline over time. And the biggest benefit with this is you don't have to auto-generate any Terraform providers. You can just bootstrap the workspaces, seed all of the context in there, so you'll have one workspace for each account in each region. This was cool, but also would result in a position where we would have a ton of workspaces. And if you wanted to figure out all the configuration for a single account, if you have 10 regions, you have 10 different workspaces tracking state, we felt like that might be kind of challenging. So we decided to kind of come up with our own approach, which was to take a combination of approach 1, approach 2, and come up with a hybrid approach. So this was kind of the final model that we settled on. And again, it's super basic here. There's only 4 accounts and 2 regions, so it looks pretty simple. I'd like you to picture an environment where there's 1,000 accounts and 15 regions that you need to support. And the concept of scale kind of starts to have a benefit of taking this approach very, very quickly. So here we have a one-to-one mapping of account and security configuration. So you have one security account, one workspace associated with it. All the regions and all the resources that need to exist with it are kind of in that single block. It's a much easier mental model to look at an account holistically. So kind of wanted to show what this architecture looks like, specifically around how we have a different bake cycle for dev, staging, and production environments. So what we do is we bootstrap the creation of all of these workspaces in an infrastructure repo managed by our infrastructure team. This is the only reliance and dependence that we have on our infrastructure team to deploy our infrastructure. So as a new account gets added, it gets added to a configuration. A workspace automatically gets created depending on if an account slides into a dev, staging, or production configuration. From there, we do all of the management in the security baseline repo. So we have workspaces that are created from the working directory in the infra repo. Everything is mapped by environment. And we use the security baseline repo for orchestration. And what we do, where we have the actual logic and the application side, even though this is infrastructure, is on the very right. We have all of our Terraform modules. So this is things like telemetry, whether it's DNS logging, VPC flow logging. You can have auto remediation modules. Pretty much any security thing or function that you need to accomplish or deploy gets put in those modules, gets sharded out across different environments, is very easy to manage. So we wanted to kind of show a real life example of how we implemented network telemetry, specifically Route 53 logging, which is DNS logs inside of AWS VPCs. And so if you think about the concept of rolling out DNS logging across all of your cloud infrastructure and all of your cloud environments, this might sound like a daunting task. Maybe you have a bunch of different VPC instantiations, you have different service owners, you have different service teams. That's actually part of the reason why we decided to write this. This could be a multi-month project. With this change, you can roll all of this out in less than a day. So what you do is you establish your Route 53 logging module, you'll test it in a dev environment. Once that looks good, you'll promote it. It will get deployed into Terraform Cloud across all of the different dev accounts, and you'll promote it over staging and eventually to production. For us specifically, for threat detection purpose, it goes all into an S3 bucket. We ingest it into our threat detection pipeline where we have support for detections, visualizations, and general threat hunting. So again, really the biggest thing that we want to highlight here is a project that could take multiple quarters, multiple different teams, something that you're maybe going back and forth for prioritization on the infrastructure side. Security now has the ownership and the accountability to come in, build a service like this, and immediately make impact without getting in anybody else's way or risking any production infrastructure. So it's this very nice concept of security ownership, which has worked very, very well for us to give everyone time back on the security side and on the infrastructure side. Now I'm going to pass it back to Olivia to wrap it all up.
All right, great. Let's recap. So what did we do? We created a platform to manage and deploy secure guardrail in our cloud environments. I know guardrail is a term we like to use a lot in security, but it's also really useful in cloud environments in general, because as we saw before, nearly 60% of cloud compromises come from very low-hanging fruit. We enabled easy collection of security telemetry. We walked through the example of Route 53 logging in our threat detection pipeline and workflows. We built a declarative configuration for security controls and applied that to all accounts in the same way, no matter what account it is. If it's a dev account, an acquired account, an account you've never heard of before, all you do is hook it up into a Terraform workspace. Everything gets the same deployment, no matter what. It's self-healing, it enables security workflows, it's declarative, and it's a source of truth. And how did we do it? As David explained, we have our different repos, workspaces enabling our promotion process following software engineering cycle of dev, staging, and prod, and we instantiate our baseline modules pulled in with their relevant version tags. So we talked through our ideal list of requirements at the start prior to building the system, the goals that we had. From a security standpoint, we do have the ability to create secure defaults in a guardrail, we can collect security telemetry, and we have centralized governance. We have higher quality security workflows with a security as code approach, with standards for testing and promoting across environments. Green checkmark, amazing. From an engineering perspective, rather than continuously going to the infrastructure team and asking them to do this work for us, we can now do this work ourselves. We're not pinging them on Slack, creating mountains of tickets, there's fewer context switching and interruptions, and we're speeding up getting things moving and giving engineers their time back. So end-to-end deployment is going from months to minutes to keep up with company velocity, and that brings us to the business perspective. We want developers to spin up new accounts and not have to worry about all this security stuff, but be confident that the company is being taken care of. We can give that confidence now, that when you add a new account, you're getting a security layer with everything we want and you need. And lastly, you. As someone working with security baseline, your life becomes easier. You have higher guarantees, it's faster to roll out changes, security as code keeps things consistent, and more specifically you listening to this talk, get to benefit from our challenges and triumphs to see if this will work for you and your organization. And that concludes our presentation. So thank you for your time and listening to our talk.